the carbon, chemically functionalize the carbon nanotube and the oxidation group oxidation groups population of the carbon nanotube. So we have taken the surface roughness of the carbon nanotube. We have only this one is a single carbon nanotube which is non-functionalized, and we check out the roughness profile, and this one is functionalized carbon nanotube. Definitely there is possible a lot of noise because we can't do very fine experiment, but we have shown the surface roughness is getting increased in the functionalized carbon nanotube. And we have done the FTIR spectroscopy. This one is pristine functionalized, pristine carbon nanotube. This one is functionalized carbon nanotube. And we have done the unsaturated polymer matrix, and we have found out there might be a possible alternation of the functionalized carbon nanotubes, carboxyl and hydroxyl group with the free radicals in the unsaturated polyester matrix. And what we have done here, we have initially done the flexural strain, and we have found out that the flexural property is likely increasing with increasing amount of reinforcement, but sometimes after a particular level of enhancement of the flexural property, the property might decrease sometime. And what happened here, that the high surface energy of the carbon nanotube during the curing procedure is re-agglomerated. So optimum dispersion level is always a desired. So particular amount of carbon nanotube within the host polymer matrix may lead to a promisable enhancement of the strength of the matrix, and also it also influences the eccentric property of the material, which is modulus, also influence the modulus predictor. And what we have done here, we have cross-checked the fracture surface of the polymer matrix. Actually, the possible agglomeration of the carbon nanotube was a very stress concentration points within the matrix. And what happened during the failure mechanism, failure characteristics of the composite sometimes alters. Actually, what happened here with the better, what we have got, the better dispersed and better mechanical property is showing very branching and very thin the river-like pattern. So it happened that there are small stress concentration points are originated within the matrix. Then have the large amount of nanoparticles have been clustered and cause the deterioration of the matrix. We also studied the wear rate. The wear rate result is pretty promising actually. The wear rate is gradually decreasing with the amount of graphite nanoparticle. And what happened here, the carbon nanotube act as a friction coefficient modifier within the matrix, and the friction coefficient also, the wear rate is reduced. And we have cross-checked the wear track, and there is a surface roughness within the wear track is also getting reduced with increasing amount of carbon nanotube. And we have done the nano indentation on the carbon nanotube to see whether the dispersion, whether to check whether the dispersion is proper and how the nanoscale characterization may influence the bulk property. And what we have found out that nano indentation hardness is getting increased with increasing amount of carbon nanotube. Also the elastic modulus, what we have found out with from the nano indentation machine by its depth sensing method, and the modulus is also varying actually, not very much but alters. And we have found out the plasticity index and the recovery index, which is H/E ratio. We have shown there is a, this was the pretty much typical in FM nano indentation impression image obtained by them.
Could you please explain why the Young's modulus and RDS are increasing with the concentration of the same